In this video, I'd like to talk about how to evaluate an inverse trig function given some ratio. We also need to keep in mind the domain restrictions for these inverse trig functions. Now, in this example, we're only going to pick on the sine function, though this is true for any trig function. And we're also only going to practice or work on angles whose reference angle is pi over 3. So what I've drawn on the left here is just part of the unit circle, and I've drawn up all the angles whose reference angle is pi over 3 and listed their cosine and sine values. Okay, so one thing that you must get clear when working with trig functions and inverse trig functions is who is who. This is a stumbling block for a lot of people, and if it's not crystal clear in your mind, it's very easy to trip over your own feet. So remember, for any trig function, right, not just sine, but for cosine, tangent, or any of the reciprocal trig functions, we plug angles into our trig functions. And the trig function, depending on what it is, will say, okay, take the opposite over hypotenuse, or the y over the x, or whatever you're working with, and it'll give you some ratio. It'll spit out some ratio. So angles go into our trig function, ratios come out. The flip side of that, our inverse trig functions work the other way around. We plug a ratio into our inverse trig function. The inverse trig function does its thing, and it tells us what angle generated that particular ratio, right? That particular opposite over hypotenuse. However, if you recall from an earlier video, we said that when you invoke inverse trig functions, there's a caveat. They come with domain restrictions. This angle here, it is only allowed to exist between negative 90 degrees and 90 degrees, right? Or negative pi over 2 to pi over 2. And if you recall, we said that is that because if you look at the general sine wave, the thing is not one-to-one. It fails the horizontal line test. It doesn't have an inverse to begin with, but we want an inverse. We want to be able to work it backwards. So the workaround, if you recall, is to say, well, let's just look there. Let's just cover all the possible outputs over some region that is one-to-one. That does pass the horizontal line test. So you can talk about an inverse if you're there. If you're only talking about these angles, feel free to talk about inverse sine. But that occurs between negative pi over 2 and pi over 2. So that's why any answer you get out of inverse sine must be an angle there. Now, again, depending on what you're using this for, maybe you take that information and run with it and go find other angles, because we saw that there are indeed infinitely many angles that reach any output, right? As long as it's within the range of sine. Okay, so let's try a couple examples and keep this domain restriction in mind. Let's say we were asked to evaluate, or maybe simplify, whatever the directions might say, but maybe we want sine inverse of root 3 over 2. So again, this is a ratio. I know it's a ratio because it's the thing we plugged into our inverse trig function. So I'm thinking on the unit circle, what ratio, I'm sorry, for what angle do I find the sine function giving me a root 3 over 2? Well, because I only drew those, that's all of them, right? The sines are all root 3s over 2s. Okay. Now, what I've trained myself to do is that as soon as I see this, I instantly draw this picture. For me, that is a visual reminder of that domain restriction. And so that I know that any angle answer I give only exists in quadrant 1 and 4, or between negative pi over 2 and pi over 2. So I know that the angle that makes sine a root 3 over 2 is a 60-degree angle, or pi over 3. And remembering all students take calculus and knowing that my answer's got to be in one of these two quadrants, I could see that it's this quadrant that would give me a positive value for sine. And so I know that that angle, it not just has a reference angle of pi over 3, but that it's actually pi over 3 itself. Let's try another example here, because that one was kind of direct. What if they asked us for sine inverse of negative root 3 over 2? All right, so again, they've given me a ratio of negative root 3 over 2. They are asking us for the angle which gets that done, right? And so there's a couple angles, well, there's infinitely many angles for which you could plug into sine and you could get negative root 3 over 2 out. I mean, I could see two of them right here, right? At this angle, my sine is a negative root 3 over 2. At this angle, my sine is a negative root 3 over 2. Okay, but we remember our domain restrictions, right? It says as soon as we invoke that symbol, that function, remember that thing only understands negative pi over 2 to pi over 2. We restricted the domain of the sine function, chopped off all the rest. So that's all it knows. So remembering all students take calculus, we can identify that, okay, we want this to be negative. That would occur down here in quadrant 4 because their only cosine is positive. So here's a very common mistake. I'm writing that first so people see it. A common mistake is people look at their unit circle and they'll go, sweet, I nailed it. This is 5 pi over 3. But that's not the answer. That is a wrong answer. It's not 5 pi over 3. You're definitely looking in the right direction. You've identified the right angle. I mean, you're good, but you're not, you're leaving the domain restrictions, because take a look at this. If I were to count around starting at 0 to 5 pi over 3, I enter an area that sine inverse knows nothing about, right? So in other words, I've left the restricted domain and I've suddenly somehow magically popped back in. All right, and so that's why I can't list 5 pi over 3 as an answer. I went outside the restricted region to get there. Instead, if I want to identify this angle or this location, but stay within this boundary set by inverse sine, I got to go directly at it. I've got to go right down to that angle. And because I'm moving that direction, that would be negative. And the distance I'm traveling there, well, it's a reference angle of pi over 3. Right? I know that I get a ratio of root 3 over 2. My sine gives me a root 3 over 2 at pi over 3 angles, because I know quadrant 1 of my unit circle. So I know that it's pi over 3 off the x-axis, and it's got to be negative because I went down to it, or clockwise rather. Okay. Let's try one more. Remember, let's take a look at cosine here. Let's say what is cosine of, well, how about cosine of root 3 over 2? Or no, negative root 3 over 2. Let's do that. Cosine of negative root 3 over 2. If you recall, well, for one, there is some different notation that can be used here. Cosine inverse, sine inverse, tangent inverse, that can all be written using arc notation. So you could have arc sine, arc tangent, or in this case, you can have arc cosine. That means the same thing as cosine inverse, so you might see either one. Okay, the thing to remember with cosine is the way we had to restrict its graph in order to talk about an inverse function, we had to restrict the graph from 0 to pi, or 0 to 180 degrees. So when you are invoking cosine inverse, it's only going to give you an angle answer between 0 degrees and 180 degrees, or 0 and pi. So if I had to go about finding cosine inverse of root 3 over 2, the first thing I would do is I would say, well, what's my reference angle? So I'm just thinking of quadrant 1 of my unit circle, and I'm thinking what angles give cosine a ratio of root 3 over 2. And again, the better we know our reference angle, the faster we can snap to those quick questions, but that's at the pi over 6 reference angle. Right, so I know that I'm talking about a pi over 6 slice right here. I know all students take calculus, so I can see where cosine is going to be negative, which is what I require, right? So I can see that Again, I don't want to fall in the trap. I know that I've got to answer here, and I could see that I would be negative in this quadrant, so that's going to be my angle. I'm counting by pi over sixes, so I guess I drew that a little high. It would be a little thinner slice. That would be 5 pi over sixes, right? Because it would be 6 pi over sixes to get all the way to half a pizza, and we're one of those reference angles off the x-axis there. So this came out to 5 pi over 6. And because I could go directly to that angle while staying within the restricted boundary, I didn't need to do any tricks like I had in the last example where I had to travel backwards. So we just get cosine inverse negative root 3 over 2. That's 5 pi over 6. Okay. So remember, identify the reference angle, and remember the domain restrictions. When you're dealing with sine inverse of some ratio, so some number, this guy's restricted from negative pi over 2 to pi over 2. Cosine inverse of some number is restricted from 0 to pi, and tangent inverse of some number is restricted negative pi over 2 to pi over 2. And specifically, it can't be pi over 2 or negative pi over 2 in the case of tangent, because tangent is undefined there. But I don't think you'll run into that case. So remember those domain restrictions, use the reference angle, and most importantly, if you're trying to get to some angle, you can't leave the restricted boundary to get there. You may be forced to just go straight directly at it. Keep up the good work.